Okay, so now we're going to be looking at adding and subtracting polynomials. And one of the key terms or things that we need to remember when we're adding or subtracting polynomials is they must have the same exponent and the same variable in order for us to combine them. And when we do combine them, we only add their coefficients. We do not mess with their exponents like we did with multiplication. I like to use colors to do this. You can do this any way that makes you comfortable. First of all, you need to make sure you're looking here in the center. This particular one is to add. The really great thing about adding polynomials is we really don't need to do anything special. We just need to add their like terms. So I just start with one of them and say, do I have anything that is like a to the third power? And I look over here into the second parentheses and I notice that I do have a minus a to the third. So I can take this term and this term and add them together. And I'm using the word add very loosely here because this is a positive 1 and a negative 4. So that is actually subtraction, and that is going to give us a negative 3a to the third. Again, remember when you're adding them, we're not messing with that exponent. All we're doing is combining their coefficients, and since he's got just an a or a 1 in front, 1 minus 4 was where we got our negative 3. So our next set of like terms here is we've got this negative 2a squared, which is like this 3a squared. Again, we're going to combine their coefficients, negative 2 positive 3. That's going to give us a 1. Typically when we have 1, especially when it's going to go in front of a variable like a squared, we won't actually write the 1. We'll just say plus a squared, and this would be our answer. And that's as simplified as we can get it, because all we're doing right now is adding or subtracting them together so that we get them in their simplest form. So now with our next one, again, we're doing the same thing. So we're going to start off, again, I'm just going to start off at the front of my parentheses. I am still adding, so I don't need to do anything special. I just need to combine like terms. I'm going to start off here with this 13n squared and negative 13n squared. But notice that when you do 13 minus 13, that would give us 0. So these actually cancel each other out, and we won't have any n squareds in this problem at all. So then we can go on to our next term, which just happens to be a positive 11n, and we've got over here a negative 3n. So we're going to do 11 minus 3. Well, 11 minus 3 is going to give us 8, so that's going to be 8n. And then we have one more set of like terms. We've got this negative 2n to the fourth, which is like this negative 6n to the fourth. Those are both negative, so we're going to add them and keep their signs. So that's going to give us negative 8n to the fourth. And if you don't like the way that that's written, you can easily take this and rewrite it. Proper math actually says that since n to the fourth has the higher exponent, he would go first. So we could write it negative 8n to the fourth plus 8n, although either one of these is considered correct. Just this is the proper format, but this is just as correct. It doesn't matter which order we put them in. Okay, so for our next example, notice this time instead of an addition here, we have a subtraction, so we're asking you to subtract it. So when we subtract, we have to do one extra step. What you're going to do is bring your first parentheses, whatever sits in it, directly down, so 3a minus 12. We're not going to mess with that, but we are going to take this negative in front of the 5a and minus 10, and we are going to distribute that negative. Basically, what it's going to do is change all of our signs. And notice that it doesn't just go to the 5a, it also goes to the negative 10. So this would end up being negative 5a plus 10. Now we can actually start combining like terms, and you can talk about that we have a positive 3a and a negative 5a, which would give us negative 2a. We also have a negative 12 plus 10. Negative 12 plus 10 will give us a negative 2. So this would be our answer, negative 2a minus 2. So number 4, same type of problem. Hopefully you already noticed that it is a subtraction, which means that that negative needs to be distributed to all 3 of the terms in that second parentheses. So again, what we're going to do is write the first one down, 8n minus 3n to the fourth plus 10n squared. And notice that I did drop those parentheses. So now I'm going to distribute my negative on the second one. That makes that a negative 3n squared. Makes that a negative 11n to the fourth. And then a negative and a negative make that a positive 7. And then we can go through and talk about like terms. We can do this in order of exponents if we want to. So n to the fourth is definitely the highest exponent in this problem. So we have a negative 3n to the fourth and a negative 11n to the fourth. Notice they are both negative, so we're going to add them and keep that sign. So that's going to give us negative 14n to the fourth. We also have like terms with our n squareds. We have a positive 10n squared and a negative 3n squared. So 10 minus 3, that's going to give us a 7n squared. Now notice that we have an 8n and a positive 7. Well, these are not like terms. We can't actually combine them. So all we're going to do is just bring them down and add them to the end of our polynomial we're writing. So this would be a positive 8n and a positive 7. And this would be our simplified answer for number 4. Okay. So number 5, I hope you notice, has both addition and subtraction. So we're adding here for the first one, but on the second one we're actually subtracting. So that means that that negative needs to be distributed to all of the things in just that last one, which means what we're going to do when we do this problem is we're going to write down everything in this first parentheses, everything in the second parentheses just the way they are, but then we're going to distribute this negative to the last one. So we still have 2x squared minus 5x minus 6. This is going to be plus 7x squared plus 10x minus 3, and then we are going to distribute that negative throughout that problem. So this is going to become a negative 4x squared, a positive 6x, and a negative 7. Okay, so now we just need to collect like terms. So I'm going to start off with my x squareds. We've got a positive 2x squared, we've got a positive 7x squared, so that's going to give us 9. And then we're going to subtract 4x squared, so that's going to give us 5. So we have 5x squared. Again, remember we're adding like terms, so we don't actually change the variable, only add or subtract the coefficients. So now we're going to look at our x's. So we have a negative 5x, we have a positive 10x, that's going to give us 5x. And then we're going to add 6x to that. Well, that's going to give us 11. So we've got plus 11x. And then the last thing we're going to look at are just our regular old numbers. We've got a negative 6 and a negative 3. Since those are both negative, we're going to add that together to get negative 9. And then we've got a negative 7, so that again is negative, so we're going to add that to the negative 9, which is going to give us a negative 16. So our answer for number 5 would be 5x squared plus 11x minus 16.